Hello, Algebra 2A. Welcome back to day 2 of lesson 28, where we are still working on simplifying rational expressions. Last time we talked about what a rational expression is, how to find excluded values, and we didn't practice that on our delta math, but that is something that will pop up throughout the year yet. And then we looked at example 1 and 2. So if you haven't watched the lesson 28 day 1 yet, that's where you would want to start today. But if you've seen example day 1 with examples 1 and 2, then you are ready to start looking at day 2. So example 3 is where we'll start. We're just continuing to simplify rational expressions today. We're going to identify any excluded values for the expression and then simplify the expression. To find the excluded value, which I'm just going to abbreviate EV, we'd start by setting our denominator equal to 0. So with fractions, the denominator is like your number you're dividing by, and you can't divide by 0, so that would be considered your excluded value. And then we just do our algebra. So I would divide by 15 on both sides, which 0 would still be 0. So 3x minus 4 is going to equal 0. Then I would add 4 to each side. I get 3x is equal to 4. And then lastly, I would divide both sides by 3, which would give me x equals 4 thirds. So there would be my excluded value, 4 thirds. Now we'll start to simplify. So I've rewritten the exact same rational expression below here. So looking first at our terms, we've got a 10 and then a 4 minus 3x in the numerator. And then 4 minus 3x, I would check to see if I can factor anything there. It's got two terms. It's not a difference of squares. There's no GCF, so I cannot factor that any further. And then 15 times the quantity 3x minus 4. Again, I can't factor that down any further. But one little trick. Whatever term is our highest degree, we're going to want to make that turn that back to positive. And kind of looking at these factors, you can see we're dealing with 4 and 3x, but this is a negative 3x, that's a positive 3x. This is 4, this is negative 4, so they're not exactly the same factors. But if I could make this negative 3x positive 3x, and then also make this negative 4, I could get them to match up. But it's a good idea whenever we are working with polynomials is to always make that leading term positive. Now what I'm going to do that is I'm going to factor out a negative 1. So I'm going to divide both of these terms by negative 1, and then that negative 1 is going to go out in front of my parentheses there. When I divide 4 by negative 1, it's going to change it to negative. When I divide negative 3x by negative 1, that's also going to change it back to, it's going to change it to positive. So I'm going to factor out that negative 1, so that's going to times the 10 and make it negative 10. Then my 3x becomes positive, and then my 4 became negative. So I divided both terms by negative 1. It just basically switches their sign. Down in my denominator, I still got 15 times 3x minus 4. And I've got negative 10 and positive 15. But I'm really just looking at the numbers. 10 and 15 are both divisible by 5, so I could divide out a 5 out of both of those. That would make negative 2 over 3. And then I got an exact matching pair, 3x minus 4, 3x minus 4. Those are going to factor out. So I'm left with negative 2 thirds. So a good rule of thumb is wherever your leading term is, you're going to want to make sure that it is positive. So if it's positive already, you don't need to factor out a negative 1. But if it is negative, then you're going to want to factor out a negative 1 to start to simplify your rational expression. In problem 4, we'll start by finding our excluded values, which I'm just going to represent with EV over here. And we're going to take our denominator, set it equal to 0. Now here's a case like I was just talking about before, is we want to make this leading term positive. So I'm going to start by dividing everything by negative 1 to make that leading term positive. So then I get 2x squared plus x minus 3 equals to 0. Now when we get into solving equations that involve a quadratic, this x squared here, we are going to use factoring. So I can kind of use hints about FOIL. So I know my first terms are going to have to be a 2x and an x. So I'll put a 2 and a 1 there. Then I'm going to try to figure out, well, how can I use the factors of -3 to make sure my outsides and insides are adding up to 1? Well, what I could do is I could put a +3 right here and a -1 right here. Then that would make my outsides 2 times -1, which is -2. My insides 1 times 3, which is going to be +3. And then that's going to equal up to the middle term, which is that 1x. So that means my factors then are 2x plus 3 and x minus 1. There's my two factors. Set those equal to 0. Now to find the excluded values, I would take 2x plus 3 equals 0, and then x minus 1, set it equal to 0, and I get my two answers. I'll get x equals -3/2 and x equals 1. So there would be my two excluded values. Since it's a quadratic equation, we'll get two separate answers that'll both be excluded values. So and to recap, I would set it equal to 0, make my first term positive, divide everything by -1, then work on factoring. And that's something we practiced back in lesson 23. Those assignments are still up in Delta Math, so if you need help factoring, there's those assignments to look at. And then I would solve out each factor, set it equal to 0. Now we'll move on to simplifying. So I've rewritten the same problem again. I'm going to start by looking to factor both my numerator and denominator. Now my denominator I already did factor. I did all the work over here, so we'll use that when we move forward here. First thing I look at my numerator, I could factor out, since each of those are even, I'm going to factor out a 2. So that would divide each term by 2, which would make this 2x squared minus 5x plus 3. And then I'm going to change this first term to positive, so I factor out a -1, so each term gets divided by -1, which makes it 2x squared plus x minus 3. Now we'll continue simplifying. So I already know that my denominator is going to factor into the exact same thing I got over there, so it'd be 2x plus 3 over x minus 1. And then I look at my numerator. So I'm going to start by putting my GCF of 2 out in front. And then I take a peek. I'm going to change colors here so it sticks out. I know that 2 and 1 need to multiply to 2. Now I need to figure out how could I multiply to +3 and then add to -5. Well, if I put a 3 right there and then a 1 right there, that's going to make 2 times 1, which is 2. On my outsides, my insides would be 1 times 3, which is 3, and that's going to add to that middle term 5. But my middle term's -5. Well, that would mean I just use two negative terms. So now 2 times -1 is -2 plus -3 is going to equal -5. Okay, so that means my two factors will be 2x minus 3 and then x minus 1. So there's going to be my two factors that I'll use, and we'll rewrite those over here. We'll get 2x minus 3 times x minus 1. All right, now we're ready to look to see if there's any factors of my trinomial that was in the numerator to my trinomial in the denominator. We look, we've got an x minus 1, cancels. This is 2x minus 3, that's 2x plus 3. They are not the same, so I would not be able to factor those out. And then 2 and -1 don't have anything in common. So my final answer would be 2 times 2x minus 3 all over -1 times 2x minus 3. And that would be my result. So there's my final answer. And then when we get to Delta Math, that would be just the result you would put into your answer key. So in example 5, we are going to write an expression for the surface area of a cube and then the volume of the cube. So right now I'm going to start with unlike sides. So volume is x times x times x. So if all three of those sides are unknown, I would do length times width times height. That's going to be x cubed. And remember, we are dealing with a cube, so that would mean that each edge of your cube is going to be the same. Now surface area. So surface area, there's 6 total sides on a cube, and each of those sides would be the area x squared. So 6x squared is going to be the expression for my surface area. Now the ratio would just be writing this as a fraction. So my ratio would be 6x squared over x cubed. Now if you look at this carefully, these two x squared, those two x's are going to cancel out 2 of these. So I'm left with 6 over x. So there would be my simplified expression of the surface area of a cube compared to its volume. Now find the surface area to volume ratio of a side length of 12. Well, if I put in a side length of 12, that would be 6 over 12, which is going to equal 1/2. So there would be my ratio. So for every 1 unit in the surface area, that's equivalent to 2 units in my volume. So 1/2 was what 6/12 would simplify down to. You are now ready to look at day 2 of Delta Math. I did go through some Delta Math problems at the end of the video for day 1. So if you're having trouble with entering your answers, you're going to want to check the end of the video for day 1 on lesson 28, or you can click on Delta Math, click on Watch Help Videos. That's going to be where there's videos to walk you through the problem you're working on. Well, thanks for joining, and you are now ready to work on Delta Math lesson 28, day 2, and we'll see you next time.